Hello. Today we are going to be presenting Julia and Excel. Julia and Excel is a package for enhancing your spreadsheets with the Julia language. Julia and Excel is an add-in to Microsoft Excel that empowers you with capability for accessing the Julia language and Julia's rich package ecosystem from within the world's most popular spreadsheet application. Julia and Excel provides you with a transparent method for calling Julia functions directly from Excel. It enables simple loading of files into your associated Julia process directly from Excel's Office ribbon user interface. In addition, Julia and Excel provides functionality for switching between multiple separate Julia environments. When one of those Julia environments is Julia Pro's Juno IDE, Julia and Excel and Juno can be used together in the development and deployment of Julia functionality to Excel users. The primary interface between Julia and Excel is the jlcall function that is made available within Excel. jlcall provides an API for calling a Julia function and passing its associated arguments. Those arguments can be either direct arguments, such as floating point numbers or strings, or can be cell references to existing cells or cell ranges within your spreadsheet. jlcall supports executing functions as either standard Excel functions that return a single scalar value to a given cell, or Excel array functions for cases where the Julia function can return a vector or matrix of values. In this video, we will show you a number of different examples for how you can make use of the functionality of Julia and Excel to enhance your Excel-based workflows. We will see a few examples of calling basic Julia functions and operators that are part of the base Julia distribution. Next, we will perform a few operations on functions that take vector and matrix inputs and return outputs that are called as either standard Excel functions or Excel array functions. Then we will define a few functions and load packages within Julia that are made immediately accessible to the associated Excel session. Subsequently, we will show you how to load functions saved in Julia files directly from the Excel user interface. And finally, we will show you how you can use Juno in conjunction with Julia and Excel to develop and deploy new Julia functionality to your Excel session. So let's get started. First, let's minimize our PowerPoint slides and start a new Excel session. With this particular Excel installation, you will notice that there's a Julia tab included in Excel's Office ribbon. You'll also notice, so here's our Julia tab, and you see the ribbon. You'll also notice that a Julia terminal session has been launched automatically. Let's maximize this. The Julia tab contains functionality for launching a new Julia session, selecting and loading Julia source code file into the associated Julia session, changing over the port number on which the current Julia and Excel session attempts to talk to Julia. This functionality will be seen later when we attempt to connect to Juno. And finally, there's functionality for reconnecting or terminating a connection to Julia on the current port that is available with these final two buttons. The Julia session that was launched by the Julia and Excel add-in to Excel has started a server that is listening for instructions on the TCP port listed at the top of the Julia window. You see this TCP address on which a variable con is bound inside of our Julia server session, and the TCP address as defined inside of the Excel window. This server listens for messages sent from the Excel session, processes any received messages to execute a desired Julia function, and sends a result message back to the Excel session. Now let's try a few examples of using jlcall to access Julia functionality from Excel. First, let's just call a few operators on some scalar data. I'll populate a few cells with some random values and we'll just perform a multiply and exponentiation on those values. So first, let's do some string data. Hello Excel, and say jlcall multiply A1 B1, and you can see that the multiplication operator is string concatenation in Julia. And now let's create some random data and copy that to an Excel. And we'll say take the first value to the power of the second value. So we'll use the exponentiation operator and say A2 times to the B2, and there we go. Here you see the syntax for the use of jlcall involves passing your desired function or operator as a string in the first position, and subsequent arguments are either numbers, strings, or cell and range references to existing cells containing numbers or strings. Those two jlcall entries are examples of functions that transform scalar values into other scalar values. Next, let's show how to use a function that transforms an array of values into a scalar. A good example of that type of operation is the mean function. First, let's set up a vector on which we can operate. And we'll say, make it 1, 2, 3, 4, and 5. Okay. And here we'll say jlcall mean A4 to A8. And the average of the numbers 1 through 5 is 3. When a function returns an array, the execution of jlcall must be performed as an Excel array function. To execute as an array function, one first needs to highlight the set of cells into which the results will be returned, and then execute the jlcall using the Control-Shift-Enter keystroke combination. Let's perform a few examples. First, we'll create a 3x3 matrix of values. So we'll say rand, and then copy this guy into a 3x3 matrix. And next, create a vector, also some random values. Okay, now let's highlight our output cells. Say equals jlcall. Do a multiply of A10 to C12 by E10 to E12. And then we'll execute that operation using the Control-Shift-Enter keystroke combination. So there we get our matrix vector multiply of these two arrays. All right, and similarly, we can slightly change this operation to perform a linear solve just by changing the multiplication to a backslash. And in that case, we've done our linear solution of this 3x3 and 1x3 system. One of Julia's most basic strengths is its built-in linear algebra functionality. And jlcall provides direct access to all of that functionality, including eigenvalue computation, singular value decomposition, and many other routines that are part of the core Julia language. Now let's try adding some new functionality into our Julia session and accessing that functionality from Excel. First, we will test if there's no, let's call it add to function accessible from Excel or defined within the Julia session. So here we can say, is there an add to? No, it's undefined. And so if we were to attempt to access, okay, we'll re-execute that. Attempt to access that function, jlcall add to, let's just say it'll be a one argument function. Let's try to add 2 to 3. Well, that function is not defined, so it gives us an invalid API. But now, if we go down to Julia and say add 2 of x, and just say that's x plus 2. Alright, now if we go back to Excel and execute the function again, we can see that it gives us the result of 5. So once you've defined a function inside of your Julia session that's running a Julia and Excel server, that functionality is immediately accessible within your Excel spreadsheet. Defining new functions and loading existing packages into scope within Julia is necessary to make functionality available to Excel. As a test, let's make the geometric mean and generalized power mean functions from Julia's stats-based package accessible to Excel. Once again, if we try to test whether these functions are available here, say geomean, it's undefined, or genmean, but let's also go up here and say equals jlcall, geomean, A1, A4 to A8. Well, it's an invalid API, but now if we say using statsbase, and say geomean, oh, it's a function that's been defined, so we can go back, execute that, and we say we have our geometric mean, and we could say jlcall of genmean of A4 to A8 with P of 2, and we get our generalized power mean. So once you load a package into your current Julia session, all of the functions within that package that have been exported are immediately accessible to your Julia and Excel session. But in case one doesn't want to always have to manually enter commands into the Julia terminal session, Julia and Excel provides capability for loading functionality stored within Julia source files directly within your current Julia session. So let's look at an example source file by starting up Juno. So let's change the size of this window a bit. Okay, and let's launch Juno. Alright, you can see we've got an example here that I've already put together that makes use of the Optim package. So Optim is a built-in package with Julia Pro that provides pure Julia functionality for performing various types of optimization operations. In this example, we're going to determine the minimum of the Rosenbrock function, defined here, using two separate solvers available in Optim. To load this source file within our Excel session, we go to the Select Julia File button and browse to our example file. And when we say open, what that does is populates this field with the path to that particular file. And to load that file into our Julia session, we can hit the Include Julia File button. And in that case, you can see that we now have an LBFGS function that's defined and a Nelder Mead function that we've defined. And let's then say equals jlcall of Nelder Mead and pass it an array reference, so let's go here, A4 to A5. We can call either the LBFGS or Nelder Mead functions that have been defined in our source file using jlcall. Doing so requires us to pass in a two-element vector as the input argument for the initial starting point of the solver. The two wrapper functions are defined to return the minimum value as calculated by Optim's optimize function for each of these solvers. So let's change that to LBFGS. And we get the minimum from the BFGS solver. As a final set of examples, we will explore how Juno and Excel can be used together in a coupled workflow via Julia and Excel. So let's first close out our current Excel session and start up a new one. In In this example, we will load a separate spreadsheet that contains information related to a number of distinct financial securities. We will use functionality defined in Juno here to get required pricing information from Yahoo Stocks and compute the associated yield on those securities. First, let's load the packages required directly within Juno. So here we say Shift-Enter. That executes the code directly within the Juno editor. And let's test getting some historical data from Juno. And finally, we'll define our function for extracting that historical data to get the price, and we'll call it on one of our securities. Okay, so that's the function we're going to end up calling in this price column. Next, from within the Juno session, let's load JuliaInXL and start a new JuliaInXL server process. So we can see that it's bound on a port 9998, whereas the Julia session that was started by Excel automatically is bound on port 9999. So in order to connect to the JuliaInXL session running inside of Juno, let's edit the port number. You can see, all right, we've updated our TCP port connection. And now let's go ahead and define the functions that we're going to need to apply a discount factor and compute the yield of our security. And test that that's working. Alright, we get a value here. So now that we have this defined inside of Juno, let's calculate these entries from within Excel. So with all of the necessary functions defined inside of Juno, with a connection made between Juno and JuliaInXL, we can calculate the price and interest for each of these securities using functionality that we've defined in Juno. So this completes our introductory tour of JuliaInXL. If you wish to obtain a copy of JuliaInXL, it is available as part of the Julia Pro Enterprise Edition. For more information about JuliaInXL or any other product from Julia Computing, please contact us at info@juliacomputing.com. Thank you.